Okay, so here we go on chapter 2. It's all about functions. So I'm starting this with a couple of functions, f of x and g of x. And if you just find f of 8, I hope that was easy as pie. You stick the 8 in there and you get square root of 8 plus 2 is square root of 10. And that one doesn't even break down because you could say root 5 and root 2, but neither one of those is a perfect square. So this doesn't actually simplify it at all. So you just leave it as root 10. The next one, g of 2, you stick a 2 in here, and then you get 1 over 2 plus 3 is 5, 1/5. Raise your hand if you had those right. Okay, good. Now let's try a little more complicated stuff. What about f of, not x, what if it's f of x minus 4? Figure out what f of x minus 4 is. Pause for a moment. Okay, you should have said, here's f of x. And you said to replace the x, Mr. Server, with the x minus 4. There we go. And then simplify it out. Square root of x and the minus 4 and the plus 2 would make minus 2. Raise your hand if you had that one right. Okay, good. Now, let's go back to these originals and just say, what if I wanted the domain of f of x? Remember how to do domain? You set what's underneath it greater than or equal to 0. Very good. If you make a picture of it, yes, it would look kind of like this, and that helps to do domain too. But in case it doesn't work out so nice, it's whatever's underneath the square root has to be greater than or equal to 0. Okay, so the domain of f would be x plus 2 needs to be greater than or equal to 0, x greater than or equal to negative 2. So do you get why it needs to be bigger than negative 2? Because what if you stick in negative 3? Then you'd have a negative underneath the square root, which would be bad, right? Okay, so there's the domain of that function. Is you set the under root, I called it, bigger than or equal to 0. So the domain of f would be x has to be bigger than or equal to negative 2. Why can it be equal to negative 2? Why can I have a 0 in here? Because the square root of 0 doesn't crash. It's just 0. All right. Would you please find the domain of g for me? I'll pause for a second while you figure that one out. Okay, you should be thinking, if I want the domain of g, that doesn't have a square root in it, but the domain really means what can I safely feed this function? And you can feed it everything except what? Negative 3. So another way to say it is x plus 3 cannot equal 0 is the rule. So I subtract 3. X cannot equal negative 3 is your domain. And really, if you just wrote that, technically it's wrong. You're supposed to say all real numbers except x cannot equal negative 3. Is there another way to write that? Yeah, you can put a number line. Remember the other, this is the number line way of writing it. And last but not least, negative infinity to negative 3 union negative 3 to infinity. Remember what that's called? Something with an I. Interval notation. Good. Okay. So there's some stuff on domains. Next, if I'm going to look at this, and I'm trying to see if it's a function or not, do you remember the rules on this? Is this a function or not? No, because it doesn't pass the vertical line test. Okay, how about this? Is this a function or not? 2 comma 3, 2 comma 5, 2 comma 7. Is that a function or not? The way it works is, here's a way to do it. Graph them. Think about this. If you graph them and it passes the vertical line test, you know what I'm saying? It's kind of a cheat way to do it. But another way to do it is to say, did any input ever give you more than one different output? Yes. The fact this came out to 3 and it came out to 5 was a bad thing. That's not supposed to happen. And think about it. If you graph it over 2 and up 3, over 2 and up 5, they're making right above each other. They would not pass the vertical line test. You know what I'm saying? All right. So the last way is, here's another one. Is that a function or not? Well, I don't know what the graph looks like. I actually do, but you might not. But do you remember the rule is if you can solve it for y and get only one equation, then it's a function? Solve that for y. Did you just do the square root on both sides? Some of you just sitting there. You're not going to learn anything by just sitting there. Square both sides, good. Did you get absolute value of y? Did you remember that? That's a big deal because that means I have two answers. Y is the square root of x and y is the negative square root of x. And in case you've forgotten, y squared equals x is kind of like the opposite of y equals x squared. Y equals x squared is a parabola that looks like this. Y squared equals x is a parabola that looks like this. And I want you to think about y. See, it's a square root. And it's also the negative of that square root. See, it's a parabola going this way. So, does it pass a vertical line test? No, and therefore it's not a function. So what's the rule? You can only get one y equation. If you can solve it and get one y equation for it, then it's a function. Okay, next. I think domain and range from a picture should be pretty obvious, but I don't know. Let's say I have this one. It's got an asymptote here, and this is at 8. Would you tell me the domain and range for that from looking at its picture? Okay, you should have said that domain, which is going this way and this way, is from negative infinity to positive infinity. And its range was from 0 to 8. Raise your hand if you had that one right. Good. Incidentally, this is not in this chapter, but if there was doing the inverse of this, and I said, oh, by the way, this guy has an inverse. What's the range of the inverse? It's the domain of the original. Okay, good. Okay, next. As you're thinking back to these functions, do you remember how you could have both a square root and a denominator in the same problem? What's the domain of that one? It's got to do two separate things. And I always encourage kids to put their answer on a number line because I think that's the easiest way. You can do it in interval if you really want. I want to pause for a second when you try that one. Okay, the top part goes like this. The under root, x plus 3, needs to be greater than or equal to 0. Subtract 3, x greater than or equal to negative 3. So negative 3 should figure prominently in your number line. Next, down here, x minus 7 needs to not be 0. So x needs to not be 7. So here's 7. That also figures prominently on the number line. Now, how do you figure out the rest of it? You test intervals and check. Granted, it should work everywhere else, but let's just check. Let's stick in a number like 8. If I put in an 8, does the top crash or does the bottom crash? Nope, so it works. This is called testing intervals. Next, let's put in, what's my favorite thing that's between these two? 0, because 0 is so nice because everything just cancels. And that's square root of 3 over negative 7. Although it's a weird number, does it crash in any way? No, so it works. And this is, the last one's like negative 4. And if I have negative 4 in here, if I put in a negative 4, do I have a problem? Yeah, so it doesn't work out there. So, good thing we tested it and we didn't just assume that it was going to work everywhere except those spots. Because it does not work right here. I'll double check it. I'll put in like negative 5 once and try that. Put in negative 5, I have a square root of a negative. I can't have that. Now, why is that? Because really, this was x is bigger than or equal to negative 3. So I have one last thing wrong with my graph. Yes? Negative 3 itself works. Very good. You should check those too. Negative 3, when I stick it in here, becomes square root of 0. That's not a problem. 0 on the top of a fraction, still not a problem. 0 divided by anything is just 0. All right, and then check 7 just to be safe. I put in a 7 here, and oh, the bottom will crash. Dividing by 0 is not good, so that one I leave empty. Oftentimes they will ask you to put this kind as u undefined and this kind as a 0. And the thing is, when this thing equals 0, it's not crashing anything. Yes? You don't have to. In calc, they'll ask you to. All right, so you could cross this off or just not shade it, but. All right, and the last topic, we had these things I called Franken functions. Remember how it was a function where in this zone it was like an absolute value, and in this zone it started to become like a quadratic, and then in this zone it was just like a line that came up to here. And I said, in the real world, where are all the problems? On the borders. Do you get that we have a problem on our border here? One of these things is goofed up. Which one? Well, it's hard to know unless I look at the function, but do you get that there's an issue right there? I've got two things that seem like they think they own that spot. And if they both do, then it's not a function because it's not passing the vertical line test. So, all right, here's a typical equation form of this. You get f of x equals, and it's a big bracket thing. Ooh, that was an interesting one. Try that again. F of x, and we'll say it's x squared plus 2 when it's from negative infinity to 2. And then we'll say it's absolute value of x plus 1 when it's from 2 to 4. And let's say it's square root of x plus 7. No, let's make it minus 5 from 4 to infinity. I'd like you to sketch what you think that looks like. That's our 12-minute warning till end of the hour, but that's totally okay. I'm not expecting you to have any time in class because I haven't given you really any homework for today. This is just a review of chapter 2 for the final. Okay, ready or not, here I go. So my borders are at 2, positive 2 here on the x, and 4. Raise your hand if you had your borders in the right spot. That's what I'd always start with. Next, I know that these can be tricky to do. You want to probably make an XY chart. So this is that whole zone. I'm going to call it the red zone. In the red zone, I need x, y, and I'm going to stick in some numbers that are in the red zone. X equals 2. Does this guy own 2? Nope. The next one owns the 2 because it says that it has the 2 in its little group. So this is everything up till 2. But I'm going to still stick in 2 into this function right here and get 2 goes in. I get 2 squared is 4 plus 2. 4 plus 2 is 6. Why am I doing that? Because at 6, right there, I'll have an empty spot. Then I'm going to stick in, what's the next number I could logically pick? How about 1? Something further back this way. So I'm going to stick in a 1, and I get 1 squared plus 2, which is 1, plus 2 is 3. So then I have over 1 up 3. 1, 2, 3 is a dot right there. And then maybe if I get one more point, I can start telling if this is a curve or a straight line. Oh, wait, I remember what this is. It's a parabola that's shifted down a couple. All right, if I put in 0, put in 0, I get 0 squared plus 2, which is 2. It's not shifted down, it's shifted up a couple. Okay, there we go. And yeah, now it's making sense to me. I can remember what this kind of looks like. And I can just get the rest of it there. Okay, next is this guy. It's an absolute value that's been shifted 1 to the left, but it's not here shifted 1 to the left. It's like this shifted 1 to the left, which is kind of like that. So exactly where should they go? Again, XY chart comes in to save the day. X, Y. I can stick in, lively marker. I can stick in anything between 2 and 4. How about 2 itself? If I stick in 2, this becomes absolute value of 2 plus 1, which is 3. And I'm going to go over 2 and up 3, and there's a dot right here. That's kind of weird, but it's right. It's underneath this empty dot, so it's okay. It's not breaking the vertical line test. Now I'm going to stick in 3. I get absolute value of 3 plus 1, which is 4, and over 3 and up 4. There we go. And it looks like this is going to be a straight line up to here. And then who owns 4? It's kind of like who owns Kashmir. Is it Pakistan or is it India? Who owns 4? The square root one owns 4 because it's got a bracket here. So I have to have an empty spot here. Now the square root one owns 4, so I'm going to do an separate XY chart for that guy. Stick in 4. 4 minus 1 is 4. Wait a minute. 4 minus 5 is square root of -1. What's that? Doesn't exist. So there's a gap here, and that's okay. It's okay to have gaps in your function. It still's a function. Now I'm going to put in 5. Is that going to break? No, it's the square root of 0. What is the square root of 0? 0. So over 5, up 0. And there's a dot right there. And I kind of know what square roots look like from there. It goes like that. I should have put that a little further over. There we go. That one was kind of tricky, but that is a good example of one of those Franken functions, or technically called a piecewise defined function. Defined in pieces. Okay, one more topic. If I give you this, and I wanted the y-intercept and the x-intercept. Can you recall the tip I've given you? The y-intercept is where x equals 0. Y-intercept is where x equals 0. And the x-intercept is where y is 0. Take a moment, figure those out. Well, the y-intercept is where x is 0. That's a 0. 0 squared is 0 minus 16, so it's 1 over -16, so it's -1/16. If I wanted to write that as a point, since it's the y-intercept, it's where x equals 0, I could write 0, -1/16. And the x-intercept. The x-intercept is where y is 0. That's where this is 0. But this one's a trap. It's a trap. They used that again in the new Rogue One movie. Did you notice that? It was said this time where it really wasn't a trap. I think I thought it was a trap. But anyway. So 1 over x squared minus 16. Can you make this thing equal 0? No, because the top's 1. How are you going to take 1 divided by something and have it equal 0? You can't. So what was the question? The question was, what is the x-intercept? And what would you say? There are no x-intercepts because you can't make y equal 0. Remember, if you make the top 0, you're finding the zeros or the x-intercepts. You make the bottom 0 and you're making the thing disappear. And if I ask for the x-intercept, I'm asking for where y equals 0. So here's another fancy way to ask you something. What did I just ask you for? Y-intercept, because I made x be 0, see? Or what if I ask you this? I just made y equals 0, so I must be asking about the x-intercepts. Okay. Okay, I think that's a good review of the stuff from chapter 2, and that's all I have for that video.